the third challenging problem in complex number is, I think, really difficult. No? It's really difficult. Okay, so if you can solve this one to evaluate the power of a complex power of a complex number. Okay, so we call this one evaluating the complex power of a complex number. So you can see here that you have the square root of 3 plus, the 1 plus j2 root of 3 plus j4. Okay, now if you encounter this kind of problem, you need to transform the radical sign into an exponent. Okay, exponent. So you want to transform that one to exponent, so you will have this form. Okay, basically don't be confused. So the exponent of this one, 3 plus j4, is 1 over 1 plus j2, or the inverse of the 1 plus j2. Okay, so that's the first step. Now you need to organize, or make sure that you copy your complex number well and transform it into exponential, or I mean this form, no? With the powers instead of the radical sign. Okay, you can express a radical sign into an exponent in that case. No? So here we transform this the base, we call the base complex number, the 3 plus j4, into into an exponential form. So the format is actually, the 3 plus j4 is simply 5. Actually, this is 5 angle tangent of inverse 4 over 3. But we know in the polar form, we can transform that one into exponential form, so which is in that other side, okay, the right hand side. Okay, 5e to the j tangent inverse of 4 over 3. So that's the equivalent expression of 3 plus j4. Okay, so we can put that way. Okay, so we replace the rectangular form with the equivalent exponential form. Then if you notice, we also evaluate the exponent, or the power, into a normal rectangular form. Okay, to make it simple. How to do that? You can use your calculator, or what you can do is you multiply both the numerator 1 and the denominator 1 plus j2 with the conjugate of the denominator, which is 1 minus j2. Then you will end up getting this value, 1 over 5 minus j2 over 5. Okay, so having solved this, actually you need to exponentiate. Okay, we call this one exponentiate the expression. So what I mean is that you take the natural logarithm of the expression, but you exponentiate that one. So basically, if you evaluate this one, e and ln will cancel each other. Okay, so we call that one exponentiate. So, and then now take note, ln and exponent will cancel each other. Okay, so basically if you distribute ln to the terms, so this becomes that one. Okay, so take note, the ln here cancelled out because you have the ln and then you have the exponent. Okay, so here this becomes one term. Okay, so there's no exponent anymore because the ln is distributed to 5 and then the exponent term. Okay, so you have here. Okay, so that one, instead of with the e, so you cancel the e because of the ln. Then but the 5, you still remain the you still retain the ln. Then yep, you just distribute these terms to each side, so you will have that one. Okay, so very simple, you just distribute them, and you see there's a j here, and then you have a j here, so j times j, -1 times negative, so this becomes positive. Okay, and then you just simply actually 2 over 5 times ln 5, then so basically this one here is a, okay, so you might wonder, is it in degree form? Actually, you can use in a degree form, but notice this one is a how you call it, it can be radian. So actually, if you want to compute this using your calculator, make sure that this one is in radian form. Okay, so the answer here should not be in degrees because this one is not in degree. So and radian actually is not a unit, it's just an expression or radian. So anything that is not degree is radian. So since this is not degree in degree form, so make sure that you are in the radian mode. Okay, then yeah, so you have an expression of this one. Okay, e to the, actually this is the complex part and then this is the real part. Okay, and what you can do next is to separate the complex and the real part. Okay, so that's the real part from this side here, and then you have the other side. Okay, so I hope you understand this expression. So if you add two exponents, basically you can separate them by multiplying. Okay, so I hope it is easy for you to follow that the sum of the two exponent of e to the power of, yeah, two terms, two sum of terms, so you can actually express by multiplying them separately. Okay, so here you can actually use your calculator to solve this one. Okay, so this is like a coefficient of this term. Okay, you can call that one a coefficient. Okay, and then actually if you follow, this becomes the modulo r, and then this one is the angle theta. But the angle theta here is not in degree but in radian form. Okay, so this is the same as the expression here. Alright, so if you follow, so the same expression. So actually that's r angle theta. Okay, so you have here your final answer. So if you compute that one separately, so you will have r e to the j theta, right? So theta here is 0.2985, and as I said, that's in radian form. And then here you calculate the modulus, that's 1.8166. Okay, so if you are required to present in degree form, so you convert that radian to degree, which is 17.10 degrees. Okay, that's it. Very simple. If you're dealing with the complex power of a complex number, don't forget to use the exponential form. Okay, exponential form is intended for this problem. Okay, so I think that's it. Thank you for